Picture this: the Earth's magnetic field, our planet's protective shield, suddenly becomes half as strong as it is today. What would that mean for us, for our technology, for life as we know it? To understand the potential implications, it's first important to understand what the Earth's magnetic field actually is. Like an invisible force field, it's generated by the churning of molten iron and nickel in the Earth's outer core. This magnetic field extends out into space, creating a protective bubble known as the magnetosphere. Its job? To deflect harmful charged particles from the sun and cosmic radiation from reaching our planet's surface. Now imagine that this protective barrier becomes half as strong. What could happen? Firstly, we'd have increased radiation exposure. With less protection, more solar wind and cosmic radiation could reach us, potentially leading to health problems like higher cancer rates. Our technological infrastructure could also be at risk, as these charged particles can damage sensitive electronic equipment, including satellites and power grids. Secondly, there would be changes to the auroras, those stunning natural light displays seen in the polar regions. These lights are the result of charged particles from the sun interacting with our magnetic field. A weaker field could change the intensity and frequency of these lights, even causing them to appear in unusual locations. Next, we have to consider the impact on navigation. The Earth's magnetic field is a natural compass for many migratory animals and certain bird species. A weakened field could disrupt these natural navigation systems, causing potential disorientation and confusion among wildlife. We'd also see more geomagnetic storms. These are disturbances in the Earth's magnetosphere that can disrupt communication systems, GPS navigation, and power grids. They could become more frequent and intense with a weaker magnetic field, leading to widespread disruption and economic damage. Lastly, the Earth's magnetic field helps retain our atmosphere by deflecting the solar wind. A weaker field could result in gradual atmospheric erosion, potentially leading to long-term changes in our climate and atmospheric composition. What could we do in the face of such changes? We could develop advanced radiation shielding technologies for spacecraft habitats and electronic devices to protect against increased radiation exposure. We could invest in early warning systems for geomagnetic storms to minimize their impact on critical infrastructure and communication networks. And we could increase research efforts to better understand the dynamics of Earth's magnetic field and monitor changes over time. So, a world with a weaker magnetic field presents significant challenges, but it's also a world that encourages us to innovate, to adapt, and to continue exploring the mysteries of our universe. After all, the Earth's magnetic field isn't just a shield. It's a testament to the dynamic, ever-changing nature of our planet.